So let's talk about regressions and git bisect. Today what I'm doing is troubleshooting this bug that you see on my screen right now. This bug's a regression. So what that means is this is a thing that used to work that no longer works. And obviously regressions are something you want to avoid. You don't want to go around breaking things that used to work when you're writing software. So generally what regressions mean is that you have a hole in your test suite. There's something that you've tested for, or sorry, there's something that's occurred that you have no tests that guard from breaking. So generally, the way I approach regressions is I write a test that actually reproduces the regression, and then I go about trying to figure out what caused the regression. A really good tool to use for that is git bisect, and that's what we're going to do right now, because in this particular case, I don't know what's caused this regression. So in order to do a git bisect, what git bisect does is it just does a binary search through your git history, right? So you start off at some known good or known bad revision, and then you tell it, this revision's good or this revision's bad, and then you tell it a known, other state revision. So in this case, I'm going to start off with a known bad revision and tell it about a known good revision, and then I'm going to ask Git to use a script to search through my my history and tell me which change actually introduced the error. So in order to do that, I've already gone ahead and written the test. So the test for this, I'm not going to get into what this issue is. It's not really important for this video. But the test is new persistence test. I just created a new file for it because like I said, this is a new test that we didn't have previously. And so if I had added this to an existing file, as I'm changing around between different versions of the code, Git's going to go ahead and delete my test for me. So I need this in some untracked file, or I need some like piece of my bisect script that would actually add the test back in. So I'm not going to bother with the latter one. Just having it in a different file is easy enough. So the other thing that we need to do is, you don't need to do this, but I'm going to do this, is to write a script that tells Git how to check for the problem. So I'm just going to go ahead and open up a new script called bisect script. It's going to be a bash script. And then, so each change, we're going to want to tell Git to, or we're going to want to first just do an npm install. This is a node project that I'm working on right now. So yeah, the first thing you're going to want to do is npm install, just to make sure that you've actually got all your updated dependencies. And yeah, we'll do that. And then I'm going to want to do I'm going to want to run the test that I just had. So in order to do that, I was running it previously, so I'm just going to copy this command from here. So in order to do that, I'm just going to use this command. Oops. So this command is npx mocha, and I've got all this check leaks stuff in here. Actually, I don't really need that for this. And I'm actually just going to tell it to run just my test, just the new test that I've created. So I'm just saying npx mocha test new persistence test.js. If I just did like, I could in theory do npm test here and that would work. But doing npm test instead of what I've done would just make all the tests run. And I don't really actually want to know if there's like a break in some other revision for some other tests. I really want to just hone in on this exact issue. So I want to make sure that whatever script I'm running here is focused on my exact issue. So that's what we're doing here. And then what I'm going to do is I'm going to capture the result of that. So I'm going to say result equals $? So that's the exit code from this command. So if this command fails, it's going to be a non-zero exit code, so result's going to be non-zero. If it succeeds, result will be 0. So next thing I want to do, sorry, the reason why I do that, the reason why I capture the result first is because I need to clean up my directory before I do, before Git changes to some of the things. So like when I do this npm install, npm often will add things or rewrite things to my package-lock.json, or in this project's case, the npm shrink wrap. So what I want to do here is just git checkout -- dot. So that literally just says git, go ahead and blow away all the files you're tracking for this directory and update them, revert them to the state that they should be for the current commit that we're on. And that's it. That's not it. The last thing I need to do is exit $result. So this says the result of my script, the exit code from my script here should match the exit code that this Mocha test script spat out for me. So I'll go ahead and save that. Make it chmod +x bisect script. So now it's executable. So if I just do a bisect script .sh right now, and I expect it to fail, so I'll do or echo it works. So that or just basically that means that everything that comes after the or will only execute if the bisect script failed, which is what we expect for the revision that we're currently on. And you notice we get this little it works down here. And I'm just realizing that this is 4K video on what may be not 4K screen, so apologies. Just real quick, I will, oops, this apparently was one that I was writing earlier. This is the contents of that script in case you couldn't see it before. Apologies for the resolution issues there. So now that I've done that, the next thing I need to do, I know that I'm on a bad revision because that script failed. Now I need to find a good revision. So what I'm likely going to do is just check out the last release, the last release that I know was good. So if I do a git tag, this is going to give me a big long list of releases. I believe the last release that was good was, oh geez, actually I'm not sure. I think it was 2.2.1, but we can find out really easily, right? So if I just do git checkout v2.2.1, and then if I just do bisect script so now I'm using ands instead of ors, so the ands only execute if the and means that, oh, actually should have thrown an echo there, but if I get an error, if bash gives me an error about not being able to execute this one is good, then I know it's working. I should have thrown an echo there, and yeah. But either way, so whatever comes after the ampersands only executes if whatever came before it succeeded. It's just Boolean short-circuiting, if you remember Boolean operators. Seems like we had quite a few things change in our dependency tree this time around. Yeah, so this, my test succeeds here. Ganache doesn't crash in the prior version, so so we know this one's good. So I could probably like do some more refinement to try to find a later one, but I mean, really, that's what bisect's doing for us, right? So next thing I'm going to do here, so I know this tag v221 is good, and I know the develop branch, the head of development branch is bad. So I'm just going to do git bisect v2.2.1, which is my known good one, and then develop. Sorry, it's git bisect start. Of course. So the problem I just ran into is that the tag is not actually a direct ancestor of the develop branch. So what I need to do is I need to search through my git log to figure out when this was merged into develop, this tag. So git log head. So it's been a while since I've done this. I'm just going to grab that change set and then do git log develop. Okay, so I would have expected well, that's confusing. Let me look at that error again. Oh, you know what? I probably just need to invert this. Develop the 2.2.1. Yeah, there we go. So it wants to do bad and then good. It doesn't really care about the chronological ordering. It just cares about bad first and then good second. Just to make sure, git bisect. So yeah, the ordering that I have here is bad, good. If you see that in the second line below that's on my screen right now. So you have all these optional flags or whatever, but then the first positional argument is bad, and then there's a good optional positional argument. So all right, so I've gone ahead here and started a git bisect. So that's all well and good. Git's like, yeah, whatever, I know we're bisecting now, but I could go ahead and just do like git bisect good, git bisect bad, and do my own manual testing. Instead, I'm going to tell Git to do its own testing using that script. So if I just do git bisect run dot slash, what was it, bisect script? Yeah. And now we should be off to the races. So Git is just going to keep checking out different revisions and keep running this script to determine where the failure occurred. Oh, that might be a problem in my test. Values identical but not reference equal. That's definitely a problem in my test. That's weird because the other time it passed. I'm just going to let it run and see what happens. Actually, no, I'm going to fix my test real quick. I just hit Control-C to stop it. So the problem I had before was I had two objects that I was comparing in this assert statement here, and I was using deep strict equal, and so because they were two identical objects by their data, but they weren't reference equivalent, in other words, they weren't both referring to the same exact object, deep strict equal was complaining. I'm not sure why it passed on the good revision though. That's weird. All right, so the cool thing is I can just restart my get bisect, and then I can just do get bisect run again. I mean, even if you're sitting here babysitting this as well, like there's still a big time savings and a big consistency savings, because like there's no guarantee that you're gonna not that you're going to perform each manual test the same way every single time. So, you may have some false positives or false negatives in your own manual testing, and this is just a bit more rigorous of a way of accomplishing the goal. All right, so bisect run success. And it came out to be the commit that I expected it to be. So it says AF98663 blah 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 is the first bad commit. And look at that, I was the author, whoops. And this was the commit message. And then these are the files that were changed, I believe. Not actually certain what these lines are, but either way, bisect is telling me it found my problem. So I'm already on this revision as well. So at this point, I can go ahead and start inspecting what changed and start trying to hone in on the problem a little bit more. So just to prove that it worked, if I just run the /bisect script, we'll see the tests fail in this case. And it does. So I'm going to switch back to my develop branch. Apparently I need to do like a get bisect stop maybe. How about reset? There we go. Yeah, so Git was still in bisect mode, but we're good now. So yeah, when you're done, just do a Git bisect reset, and it'll clean up the temporary state. But before we go, I'm just going to show one more quick thing, which is why this is still going to be a hard problem for me to solve. So remember, I'm the one who made this commit, right? I'm totally to blame for this, but I'm just gonna show the actual commit change itself. Maybe. Yeah, the issue was reported to a different repository than the one that actually contains the issue. So, okay, so the last thing I want to show is why this is still going to be difficult and what can be done to make it easy. If you look at this commit, like this file, the number of changes in this file were so numerous that GitHub didn't even want to show it to me at first. So there are just so many things that changed here. And I mean, you just look, I mean, so much stuff changed. And now, admittedly, I don't know how I would have broken up this commit. This was the sort of cross-cutting change that that unfortunately required a lot of files to change. But there probably was a way I could have planned it out a little bit better and made it so that like it was committed as a series of small chunks. The problem here is that basically this is a huge commit, and I don't even know where to begin to look for the issue in this commit. But at least now I don't have to worry about all of the other commits, right? Like I've narrowed it down to here. So I certainly have a bunch more refactoring to do, or a bunch more troubleshooting to do to actually get down to the root cause of this issue. But I've just saved myself a ton of time because now I know rather than searching through my entire code base, I'm only searching through the things that have changed in this commit. So that's it for me for now. Hopefully this helped. Git bisect is totally your friend. It will save you crap tons of time, especially when you're just like really scratching your head. In summary, just to make sure everybody gets it right, there's a regression. Regressions represent holes in your test suite. Patch the hole first by writing a new test. Ideally, write that test into a new file. It's fine if you copy it into an existing file later on, but when you first write it into a new file, and then write a quick script that runs that test and leaves yourself with a clean working directory at the end. And then once you've written that script, you can use git bisect to just run that script on as many change sets as it cares to test, and then it will tell you exactly where your problem was introduced. That's it for me. If you like this, please subscribe and click the thumbs up button. Thanks.